3 years I've been screen recording. Alright, so today we're doing 2.4a, which is absolute value limits. This is not on your notes, but this is just something to talk about before we get into it. How many solutions are there to this particular equation?
1. 8. 2. Wait, 2.
What are the two solutions?
Negative
5 and positive 5, that's true. And that's because, technically you would solve this two ways, right? You would do x equals 5, and then you would do negative x equals 5, right? And then you would solve for x, and you'd get 5 and negative 5. Alright? So the main idea here to understand is absolute value equations can have two solutions. Same goes for their limits. Okay, you have to look at the left and right side of their limits as well. So these are just the instructions on how to go about finding these. The main thing you need to understand from this conceptually is the fact that absolute value equations can always be rewritten as a piecewise function, because there's the piece that's the negative slope and the positive slope, and if you put them together into one equation, that's how you get an absolute value. Alright, so on this question, we have the limit of 2x plus the absolute value of x minus 3. So here's how you go about doing it. You're going to split it into two limits, the left limit and the right limit. But when you go to do the absolute value, I'll wait to talk about that. So you split it into two. And when you go to actually write what the equation is that you're taking the limit of, here's what you do. On the negative side, the left side of the limit, you're going to take whatever the original function is, but you're going to basically multiply what's in the absolute value by negative 1. Okay? So instead of being a plus whatever that is, it's going to end up being, I keep hitting the wrong button today, a minus 1. So you see how I took this, I replaced the absolute value bars with parentheses, and I have to multiply what's in the absolute value bars originally by negative 1. Does everybody see that? Anybody have any questions about it? Okay. And then for the other one, the right side limit, you just basically replace the absolute value bars with parentheses. So those are your two methods of solving. So we're going to solve this one here. To do that, I'm going to distribute that negative onto everything in the parentheses. That gives me 2x minus 3. Yes, it would be. What's 2x minus x? What's x plus 3? When we plug in 3, we get 3 plus 3, which is 6. So for this one,
is way more complicated.
well, you're going to see why we have to do it this way when you do the homework. So this one over here, you are technically distributing a 1, but we don't need to actually do that, so we can just drop the parentheses. They're not doing anything here. 2x plus x. And then we plug in 3. So we get 9 minus 3, which is 6. So on this one here, the limit holds, right? True. Okay, it does exist, and it exists at what value?
6.
Yes, it exists at 6. Good. So we can say the limit is 6 because it matches on both sides. If it doesn't match, you would say it does not exist. And I did give you a little picture of this. This is what the graph looks like. And you can see that at the x value of 3, we meet at the same point at 6. Okay? But that doesn't always happen. So now we're going to look at this one here, which has an absolute value in the numerator and denominator. So we learned from the last question that you typically want to change the absolute value sign to have a negative on the outside when you're going to be taking the left-hand limit. But what happens when you negate the top and the bottom of a fraction? If you were to negate the top and the bottom, what would happen?
Zero.
What's a negative divided by a negative?
Positive.
So why would we only want to negate the top of this one?
So it's not double negatives. It's not just the same thing.
Yeah, because if we put double negatives in, it's just going to become the same thing that the right-hand limit is. So the important thing to know about this one is even if there's more than one absolute value bar, you still only are going to negate one of them, okay? So I'm going to choose to negate the top one, but you could have also negated the bottom one and gotten the same answer. And then for the right hand limit, you just change the absolute value bars to parentheses. Now, if we try to do direct substitution here, you're going to end up with 0 over 0. What's wrong with 0 over 0?
It's not valid.
It's undefined. It doesn't tell me whether the limit exists or doesn't exist, right? The limit, people think for some reason when you see 0 over 0, limit does not exist. That doesn't mean that. It just means it's in indeterminate form. So what can we do to make this into a determinate form?
X plus 1, or X minus 1, X minus 1.
No, you're right first time. X plus 1, X minus 1. What do we call this type of factoring?
Squared?
Difference of squares.
Difference of squares. So I was just able to factor this. And now that I factored it, what can I do with the equation?
Cancel X minus 1.
Cancel these out, and I'm left with negative 1 times X plus 1. And then I'm going to plug in what for X?
1.
So I get 1 plus 1 times negative 1, which is?
Negative 2.
Negative 2. Now over here, the numerator is going to factor the same way the other one did, right? And what's going to happen with the X minus 1s?
They cancel.
That leaves me with X plus 1, which is 1 plus 1, which is?
2.
2. So does the limit exist here? No, because the left and right hand limit don't match. So that's why it's so important you do both sides of the limit, because sometimes it won't match. So if you were to graph this on like Desmos, you would see at 1 that the limit doesn't exist. So like if I go ahead and graph it for you real quick, like this, divided by absolute value of X minus 1. I don't know why this isn't working right, never mind. But you guys get the right idea. Same idea.